Okay, welcome back, and now we're going to do a few examples, and you're going to see how quick and easy taking the derivative is, and then we're going to revisit the tangent line problem, finding the equation of a tangent line. So first example is we want to find the derivative of this. So the thing is we're going to use two of the rules because we have a constant multiplied by a function. So we're going to use the constant multiple rule, and then we're also going to use the power rule. Okay, so g prime of x will equal what? 3 times the derivative with respect to x of x squared, which is going to be 3 times, what's the derivative of this? This is going to be 2x, right? Because we take the exponent down in front, then we decrease the exponent by 1. And so then this gives us 6x. Now for this example here, again, we've got a sum of two terms, so it's a polynomial. So since the polynomials are continuous, right, and polynomials are also differentiable everywhere, okay, we can go across this, so we're going to end up having a constant multiple, we have a power rule, and we have a constant. So what I'm going to do is I'm going to do this term by term, okay? So f prime of x equals, first thing we do is it's going to be 2 times the derivative with respect to x of x to the 5th plus the derivative with respect to x of 7, right? And this is just constant. So what happens? This is just going to be 2 times the derivative of this, which is a power rule, is going to be 5x to the 4th. Now the derivative of this is a constant, so the derivative of a constant is always what? 0. So it's just going to be plus 0. So we don't have to add anything. So what's the final answer? It's going to be 10x to the 4th. And we're done. Very easy. It's much easier than using the definition of a limit, right? Using the limiting process of the difference quotient. Okay, find the equation of a tangent line of f of x equal to x squared minus 4x plus 6 at x equals 1. Now before, we had to find the slope, right? We had to find the slope and we had to have a point. Well, what's the point? Haha, what's the point? Anyway. Okay, so the point that we're interested in is 1 comma what? Well, we put in 1 and we end up just adding the exponents. When you add 1, when you plug in 1, you just add up the exponents. So it's going to be 1 minus 4, which is minus 3, plus 6, which is positive 3. So it's going to be 1 comma 3. Okay? So 1 comma 3 is the point. Now what's the slope? Oh, this is easy now. The slope, which equals f prime of x, equals, now all I'm going to do is I'm going to apply the differentiation rules for sums, constant multiples, powers, right? So I'm going to do this term by term. So what's the derivative of x squared? 2x. Minus, what's the derivative of 4x? 4. Because what's the derivative of x? You ignore the 4, right? But what's the derivative of x? 1. So you get 4. Plus the derivative of 6, which is 0. And so what's the derivative function? It's going to be 2x minus 4. And so now at x equals 1, what is the slope? Well, the slope is going to be 2 times 1 minus 4, or negative 2. So the slope is negative 2, and now we can get the equation of the line. So it's going to be 3 equals negative 2 times 1 plus b. And so what do we get? We end up getting b is equal to what? Well, it's going to be negative 2, so we're going to add 2 to both sides, so we're going to get b equals 5. And our equation of the tangent line at x equals 1 for this function is y equals negative 2x plus 5. And that's it. Voila! We are finished. Have a great day.